Assalamu alaikum. Our topic today is to identify the digits of which are significant in a given number. We are going to count the number of significant figures, the number of significant digits in a given number. So there are some rules. We will discuss these rules one by one. First of all, the first rule. The first rule states that all non-zero digits are significant. According to this rule, all the non-zero digits in a given number will be significant. For instance, if the number is 192, so how many non-zero digits in this number? 1, 2 and 3. So the number of significant figures in this number will be 3. In this, the number of non-zero digits are 1, 2, 3 and 4. So the number of significant figures are 4. The number of significant figures in part C, this is only 1. So it will be 1 and it will be 2 in D part. So the first rule states that all the non-zero digits, the digits which are not zero, all of them will be significant. Second rule, all zeros between non-zero digits. So all the zeros which are in between the non-zero digits will be significant. For example, 32047, this zero will also be significant. So we have already learned that all the non-zero digits will be significant. Now the zero which is in between the numbers, like this one, this will be significant. So the number of significant figures will be 5 over here. The number of significant figures in this will be 1, 2 and 3. 0 will also be counted. 1, 2, 3, 4. 1, 2, 3, 4 and 5. And now in this, the number of zeros will be counted which are in between the digits, in between the non-zero digits. 1, 2, 3, 4, 5, 6. So the number of significant figures will be 6. The next one, the rule number 3. Before going to rule number 3, we will see this example. Over here, the measuring length is 0.6 meter and the measuring length over here is 0.60 meter. Is there any difference or not? According to the significant figures, there is a major difference. Let us see the rule number 3, which will clearly state this example. In a decimal, all zeros after a non-zero digit are significant. All zeros after a non-zero digit will be significant. For example, 0.60. So the number of significant figures will be 2. In this example, 0.60, the number of significant figures will be 2. Why this is 2? Because the rule states that all the zeros after a non-zero digit. So the non-zero digit is this. In this is 6, and after the digit 6 there is 1 0. So the number of significant figures will be 2, and in this the number of significant figures is 1. So over here the number of significant figures will be 2, 3, 1, 2, 3, 4, 5 and 6, because the zeros will be counted at the end. 1, 2, 3 and 4. In this way we will count. Now which one is more accurate? The question is which measurement is more accurate and why? So this measurement is more accurate because it is showing more number of significant figures. It is showing 2 number of significant figures, while in measurement A it is showing only 1 significant figures, 1 digit. So that's why B is more accurate. Now the practice, now this one we have done. Now question, we will move to this question. A line segment is measured using 2 different instruments and its length is found to be 4.1 centimeter with one instrument at 4.10 with second instrument. So which is more accurate and why? So students, obviously 4.10 centimeter will be more accurate. The reason is clearly that the number over here In 4.10, the number of significant figures are 3, and in 4.1, the number of significant figures are 2. So this is more accurate. Now next, we will move to the rule number 4. In a decimal, all zeros before a non-zero digits are not significant. All zeros before a non-zero digit are not significant. So, for example, the number is 0, 0, 2, like for instance, it is 0.0428. So how many significant figures? How many significant figures over here? 3, because these zeros will not be considered. So all zeros before a non-zero digit are not significant. We will not consider them. Over here it will be 2. Over here it will be 3. Over here it will be 3. Because these zeros will not be considered. They are not considered as significant. And over here 1, 2, 3 and 4, because the last zero will be considered. So in this way the number of significant figures will be counted. Now the students, the next rule, the last one. Rule number 5. Rule number 5 is for the whole numbers. For the whole numbers, it is the zeros at the end may or may not be significant. There is option. For example, in a whole number 24000, these zeros may or may not be significant. It depends on how the numbers are approximated. So if it is given that how the numbers is approximated, so it will be clearly stated in the question that how the numbers are approximated, and according to that we will tell the numbers of significant figures. For instance, over here 3800 meters, so nearest 10 meter, so we are going to tell nearest 10 meters. So 3800, so nearest tens, this is tens, so number of significant figures are 3. In 25,000 kilometer, so nearest kilometer, so it is already in kilometer, so we are going to tell nearest kilometer, so the number of significant figures are 5. In this one, 100,000 grams, to the nearest 10,000 grams, so unit 100,000, nearest 10,000 grams, unit tens, 100,000 and 10,000 till here. We are going to tell till here, so it will be 2. So number of significant figures over here will be 2. So in this way we will count the number of significant figures. Thank you.